Okay, so this is a question. Three equal charges Q, these are your three charges Q, are placed at the corners of an equilateral triangle of side A. The side of this triangle is A. A fourth charge capital Q is placed at equal distance R from each charge. Find the force on the charge. Now, what does equal distance mean here? Now, generally, equal distance might also mean that the charges are placed at the centroid, but this is not the case here. The equal distance is, in this case, is something like this. This is R, and all the charges have equal distance. Now this is the centroid here, and this yellow line QC is perpendicular to the plane of the triangle. So you can see that all the three charges will be at equal distances from the charge capital Q. Now how do we find out the force? So let's draw the triangle again. Let's draw the triangle again here. Okay. So here is a charge Q. Here is a charge Q. And we are only going to consider it right now. We are going to consider only two charges right now. So I want you to understand here that there is a right angle triangle. And the force on charge capital Q would be something like this, which will have two components, F along axis and F in this way. Now this force, the red line, please focus, these two red lines are parallel. The two red lines are parallel. So first we have to find out the net force, and then we have to find out the components. Now how do we find out the angle theta? So we'll do everything step by step. First, the force. Force is simply K small q capital Q upon R squared, because this distance is R. Now we want to find out F axis. That will be equals to F cos theta, and the other F, let's say F parallel, that will be equals to F sin theta. Parallel means parallel to the plane. This is parallel to the plane. What plane? The plane of triangle. Now how do we consider cos theta here? The cos theta is obviously equals to the base by hypotenuse, and in this triangle, if you might notice, the base is the yellow line, this line here. So this distance is R, the side of the triangle is A. We all know that the distance between the vertex and the centroid is A by root 3. So the length of the perpendicular line, this yellow line, will be R squared minus A squared by 3 root under. This will be the distance here. So it is gone way confusing. Let me change the page. Drawing another triangle. So first we need to find out cos theta. This is A by root 3. This is R. This yellow line here is obviously root under R squared minus A squared by 3. So what will be cos theta equals to? Cos theta will be equals to the base, this is the base, by hypotenuse. So root under R squared minus A squared by 3 upon R. That will be cos theta. So what will be let's start resolving forces now. This force here will be equals to axis force will be equals to F cos theta. So F cos theta is K small q capital Q, because this is small q and this here is capital Q, by r squared into root under r squared minus a squared by 3 upon r. That will be your force along axis. Now we'll have similar cases. So if you look at the triangle again, we'll have similar cases of other charges also that will have forces. For example, this is A, this is B, and this is C. So this red force here is force due to B, and this yellow force here is force due to A. Now the components along axis for all these forces will add up, and that will be equals to F cos theta. So the net force along axis will be equals to 3 times of F cos theta. Going back 3 times, what was F? Let's try to remember. This was small charge q, this was capital charge q. So k q q upon r squared. And what was cos theta? Cos theta was root under r squared minus a squared by 3 upon r. And if you multiply 3 in, k, we can do it here, k q q upon r cubed, because there are r squared into r, into root under, multiply 3 in, that is 9r squared minus 3a squared. So this is the force along axis. What about the forces along diagonals? Let's draw the triangle again. This is the force. The force along the diagonal is parallel to this line. You can see this line here. This line, the force parallel to the plane of the triangle. The parallel force is parallel to this line here. So we can assume very easily, drawing the triangle in a two-dimensional plane right now, we can assume that force due to this charge will be in this direction, the force due to this charge will be in this direction, the force due to this charge will be in this direction, and all these forces will be making equal angles, that is 120 degrees with each other. So what will be the net parallel force? The net parallel force will be equals to 0, because all parallel forces are equal in magnitude.